Assalamu alaikum students, welcome to my channel Cambridge Companion. So today we will do question number 4 of Cambridge A&S level chemistry 9701 where paper 2 variant 22 of the question number 4. So let's start it. Okay. So the first question is in industry ethanol is made by reacting ethene with steam in the presence of the H3PO4 means is the phosphoric acid. Okay, the reaction one is this is the ethanol is made by ethene with steam. Okay, so part A is saying that use the bond energy of the values in table 4.1 to calculate the enthalpy change or the reaction one. Okay, so here is the table, so we can use this table to calculate the enthalpy change. Okay, for the reaction. All right, so we have a table, and now we are just calculate. So we can see that uh, there are two. Uh, there is C2H4 and you know uh, like something H2O, C2H5OH. Okay, those we have here the table. So uh, you can uh, I think we have the two OH bond, four CH bonds, and one carbon-carbon double bond. So OH bond is a 460 we have here. So it is the multiplied 2 multiplied by 460 mm, plus 4 into we have a CH bond also. So CH bond 410. So 2 is the 2 multiplied by 410. Yes, and plus uh, one carbon carbon double bond. So carbon carbon double bond 610. Okay, plus 610. So here we what is the value of this calculation. This calculation becomes like first calculate this uh, 2 into 460 plus 4 into 410 plus 610. So it is equals to 3170, and this is the step of this, and this is uh, you can see here, and what is the value of you know uh, the types of the energy which is uh, we have 460 uh, plus the value. What is this? We have one was one. Okay, 5 multiplied by 410. 5 multiplied by ch bot. Okay, 410. 5 multiplied by 410. Okay, so this is value, and one carbon single bond we have, notice, which is 350. 350, and plus with carbon and oxygen bond, which is, yes, you can see 360 plus 360, which is equals to, okay, now just calculate it. 460 plus 5 into 410 plus 350 plus 360. Here we have uh, 3220. 3220. Okay, so we just minus the value. Okay, just 3170 minus 3220. So what we will get, um, we will get 3170 minus 3220. We get minus 50, which is means it's exothermic. Negative sign indicate an exothermic, minus 50. So here we can write minus 50. So now move to the next part of the question. Question is, reaction 1 reaches the equilibrium at a constant temperature and pressure. Deduce what effect increasing the pressure will the amount of the ethanol in the new equilibrium mixture using the is a principle of the to explain your answer. Okay, effect of the increasing the pressure. So we obviously know that the amount of the ethanol, because ethanol is the product, so the amount of the ethanol will increase if you're increasing the pressure, because the collision of molecule is very fast. Molecules will collide, and uh, amount of the ethanol increases. Okay, so and explanation, because we have increased pressure, we have a gaseous mole of the both left hand side and the right hand side. So we have the, you know there is one mole and there is one mole, so we have the two moles on the left hand side and one mole on the right hand side, so equilibrium will shift to the right hand side. We know the principle. Okay, you know principle. Equilibrium will shift to the right hand side. Because because there are lesser number of the moles on the right hand side, and increasing the pressure will favor the side which have the lesser mole, which is the right hand side. Okay, so that's why equilibrium will shift to the right hand side. So move to the next part of the 4C. The mechanism for the reaction 1 can be described in the three steps: mechanism 1 and mechanism 2. Okay, uh, we can see this is the ethene, I think, the molecule, CH2. Okay, yes. Oh, all right, we have seen the mechanism. Okay, describe the behavior of the H3PO4 in the step 1. Explain your answer. So, H3PO4, it acts like, acid. Phosphoric acid is added, and it's donate a proton. It's look like an acid, behavior as an acid, or I can write this: it acts as an acid or a proton donor, or a proton donor. Yes. Okay. Identify the species that behaves and then electrify in the step 2. Explain your answer. Which species behaves as an electrophile in the step 2? Right. Step 2 is this. So I think this is, uh, this is uh, acts like a species because it accepts a pair of electrons. Yes, it acts as a species, which is, I can write. Yes, the species are bracket the CH3. It's CH3, CH2, because this is the species. Okay, because accepts it accepts thing. I should remove and just write with the text mode. Hmm. Accepts it accepts a pair of electrons. Complete figure 4.2 to show the mechanism of the step 3 of the reaction, including the charges, dipoles, lone pairs of electron, and the Curly arrows. Okay. So describe how a okay. Sorry, we just do the part 3. Complete a figure 4.2 to show the mechanism for the step 3 of the reaction, including the charges, dipoles, and lone pairs of the electron, Curly arrows. Okay. 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 So we should to draw it. I think the lone pair of electrons, and it will attack to the lone pair, and it will attack to the hydrogen like this, and this is the electrons. Think it should be like something else. Okay. So describe how the catalyst affects the reaction. Explain your answer. Catalyst can speed up the reaction without consuming itself by providing an alternative reaction pathway or alternative route. Uh, a catalyst increases the reaction increase the rate of the reaction by producing an alternative route. By providing the alternative route by lowering the activation energy activation energy. So we have done with this part. Now move to the next part. Use figure 4.1 and 4.2 to justify why phosphoric acid or H3PO4 is described as a catalyst um, in the reaction one. Here it is produced again. So it is regenerated. Okay, it is because it is regenerated. Because it is regenerated. Now Move to the next part. Propene also reacts with steam. A mixture of the organic products is produced. Explain why propane to all is produced in the higher yield. All right. Uh, because propane to all is produced, uh, because the propane to all is produced uh, via more stable uh, carbocation. Yes, propane, propane to all, yes, propane to all is produced, propane to all is produced uh, via more stable carbocation. Yes, yes, here you can see carbocation, yes, propane to all because it's produced via more stable carbocation. Okay, so move to the next part. Describe the covalent bonds present between the carbon atoms in ethene molecule by completing the table in one. All right. So ethene is like a molecule with the double bond like this, C2H4. Should be like this. C2H4. So here you can see types of the orbital involved in the bond. So what type, type of the orbitals involved in the bond? So we know that sp2 hybridized. Okay, sp2 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 hybridized. And what about how the orbitals overlap? We know which is a direct sigma bonds. Okay, we are just for the sigma bonds direct. Mm, what about the pi bonds, which is type of the orbitals involved? I think 2p 2p 2p. We all know that 2p 2p. And how the orbitals overlap? Yes, we know, not a direct but sideways. So here we have done with the question number 4. So I will do question number 5 in my next video. Students, please like my video and subscribe my channel. Please keep supporting me. uh, I will do the question number 5 in the next video, inshallah. Okay, thanks for watching.